This is Honors Geometry, Lesson 10.1, Tangent Properties. So as an introduction to the circle unit, let's just go over some of the circle vocabulary. I'm sure you've had this before, but it'll be a quick review for you. So first of all, what's the definition of a circle? A circle is a set of all points in a plane. So it's two-dimensional, it's flat. That is equidistant from a given point. That given point is called your center. So I always think if you have a nail with a string and maybe a piece of chalk on the end of that string and you swing it around, that all those points make up the circle. The string would be your radius. It's a segment whose endpoints are on the center and up any point on the circle. And that nail would be the center of your circle. And that's how we name a circle. The symbol in geometry for a circle is a circle with a dot in it. And then you name it by the center of the circle. It's a capital letter because it represents a point. So you would read this circle A. We know that all the radii would be congruent. And the plural for radius is radii. Okay. So let's talk about a couple more segments in our circle. So if we have a segment with the endpoints on the circle, we call that a chord. If that chord goes through the center of the circle, then we call it the diameter. If the chord continues, if we turn that segment into a line, then we call it a secant. A secant is a line that intersects the circle at 2 points. If a line intersects the circle at simply 1 point, we call it a tangent, and that point where it intersects we call the point of tangency. First rules we're going to learn a lot of rules about circles, but we start with tangents. So let's go ahead and talk about some tangent rules. The first one, Theorem 10.1, says in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So if you take a radius to a point of tangency, you know it's perpendicular. So the first thing we're going to do is determine if a segment is tangent. So in other words, is this a right angle? And we know how to determine if a triangle is a right triangle. We do the Pythagorean Theorem. If it works, we know it's a right triangle. If it doesn't work, it's not a right triangle. And again, we know all radii are congruent. So if this radius is 12, I know this also is 12. And now we're going to do good old Pythagorean Theorem. So I'm going to say 12 squared plus 16 squared. And we know the hypotenuse is across from the right angle. In this case, it's our potential hypotenuse. I'm going to add the radius plus the external part so we can see our hypotenuse is going to be 20. So I just want to see if 12 squared plus 16 squared equals 20 squared. So I'm taking 12 squared plus 16 squared gives me 400. And I have 20 squared is also 400. And we remember if the Pythagorean theorem works, then we know it's a right angle. So the answer would be yes, that this segment is tangent to the circle. Okay, sometimes you'll see it like that. Sometimes you'll see it with the whole diameter. It's the same idea. You're going to say 6 squared plus 11 squared, does it equal 13 squared? If it works, you know you have a right angle. If it doesn't work, it's not a right angle. Therefore, it's not tangent. Let's look at one other type of problem. This time we're looking for the length of the tangent segment. So again, we know all radii are congruent. So if this radius is 1.5, I know this radius is also 1.5. We're going to add these two together to get 2.5. And we're looking for one of the legs of our right triangle. So we're going to say that 1.5 squared plus x squared, I'll just call it, equals 2.5 squared. And probably in the directions it said given that the segment is tangent to the circle. So I'm going to say 1.5 squared is 2.25 and 2.5 squared is 6.25. I'm going to subtract 2.25 and I get x squared equals 4. Square root both sides, and it looks like our x is going to have a length of two units. All right, oops, that's not very easy to read. Okay, let's learn another rule. Second tangent rule we learn is if you have an external point and you draw two tangent segments to the circle, those segments are going to be congruent. So in other words, if you were standing here and your friend went to one side, you went to the other side, it's the same distance. And let's go ahead and use that rule. Okay, the first thing they're going to show you is that these two segments are tangent to the circle. You can see that by the right angle symbol. And we're just going to set these equal to each other. So you have 4x minus 9 equals 15. Add 9 to both sides. You're going to get 24. Divide by 4. And it looks like x is 6. All right. And this one I call the around the corner rule. So we're using the fact that if you choose a point outside the circle and draw two tangent segments to that circle, they're the same length, they're the same distance. So if this one is 11.2, immediately I can assume that this one is 11.2. If I choose this point outside the circle and draw a segment here and it's 10.5, I can immediately assume that this one is 10.5 also. And you can see where we're going with this. And if I choose this point, I know that these two segments are also going to be congruent. We're given that this whole length is 23.2. So I'm going to take 23.2. I'm going to subtract 11.2, this bottom part. So it looks like the top part of our segment is going to be 12 units long. And if this is 12, then I can assume that's 12. So the question is, what's the perimeter of our polygon? So I'm just going to add all of these up. I don't want to use this twice, so be careful. If you use 12 and 11.2, don't reuse that 23.2. So I'm going to take 10.5 plus 10.5 plus 11.2 plus 11.2 plus, let's just say 24, and we get it looks like 79. Nope, I think I did something wrong. Hold on one second. Let me try that again. So we have 21 plus 24 plus 22.4. And it looks like the perimeter of our polygon, if I add up all of our pieces, turns out to be about 67.4. All right, let's try one more. And these are just miscellaneous problems using those two rules. Okay, so the first thing you want to do is decide what you can assume. Again, we know all radii are congruent. So this is a radius, this is a radius. So I can assume these two are congruent. So you see I have an isosceles triangle. We know that base angles of an isosceles triangle are congruent. So I know that this is also 63. We also know that when we have a radius to a tangent, it hits at 90 degrees. So I can assume that this angle is 90 degrees. You can take 90 minus the 63, let me do that. And you can see that little angle there is going to be 27 degrees. We have a linear pair here, using all our rules from earlier in the year. So I take 180 minus 63, and it looks like this angle is 117. And then to finally answer their question, what's this missing angle? We know all triangles have 180, so I'm going to take 117 plus 27. It's like 144. I'm going to take 180 minus 144, and that looks like 36. So to answer their question, what's the missing angle? It's 36 degrees. All right, here we go. We're going to see what we can assume again. And again, if it appears to be tangent, in this case, we're allowed to assume it is. So we know this is 90 degrees. And we know that all triangles have 180 degrees. So I'm going to take 90 plus 44, give me 134. Take 180 minus my 134. So that gives me what, 46. So I know that this angle is 46. Now we can see we have two radii here. And we know all radii are congruent. So if this is 46, we can assume this is 46 because we now have an isosceles triangle. So we're going to take 46 plus 46. We get 92. 180 minus my 92, and it looks like our missing angle is 88 degrees. All right, one more using our new rules. We have a point outside the circle and two tangents to the circle, so we know they're congruent. We also know that a radius to a tangent is 90 degrees, so we're allowed to assume that these are 90 degrees. We know that all quadrilaterals have 360 degrees, so I'm going to take 90 plus 90 plus 117, that's 180 plus 117, and subtract that from 360. So it looks like our missing angle is going to be 63 degrees. Okay, so we're going to throw in those new rules, our two new rules, that if you choose a point outside the circle and draw two tangent segments, you know they're congruent. And the other new rule is if you have a radius to a tangent, you can assume it's perpendicular. Please try the practice problems. Let me know if you have any questions. Thank you.